talk to you about what we did on our notes today. So we did take that post quiz. As soon as I know if you're gonna be back here soon, if you're gonna be back in the next few days, I'll just hold off and have you take it then. But if not, then I may post it on here for you to take. All right. So today we did the first part of chapter 7 notes. So I'm gonna kind of walk through and talk about this. All right. So the first thing I did is we talked about what paper is composed of. So paper is composed of C6H10O5. So my first question was, okay, knowing what we know from last year, I'm going to make this larger. Knowing what we know from last year, how many carbons are there? Well, you look at the subscript here, and the answer would be 6 carbons. How many hydrogens are there? Look at the subscript, there are 10 hydrogens, and for oxygen, you're looking at the subscript and there are 5. So that's all you have to do on that part. So then what I did is I handed them a piece of paper. Sorry, I'm trying to turn on my smartboard, it's not going on. I handed them a piece of paper and I said, just make some observations. Now I know there's not like a ton of observations you can make about lined paper. No, why my board's not turning on? I'm sorry, look, it's like you're really in class with me. There we go. There's not a ton of observations you can make about lined paper, but there are some, right? Like, I mean, the lined paper that I handed them was pretty thick. It's a lot thicker than the stuff I buy. It was left to me by a student who had paper left over last year. And they were like, it's expensive paper. It was 5-star, I believe. There was like a little plastic strip that ran along the side. And then just visual observations, like, yeah, it's got blue lines on it. There's a red line that goes up and down on it. So just anything like that. So then what I did is I set the paper on fire, and I said, write down observations of the paper during and after burning. So during burning, you could see what the kid said, you could see smoke. You could see some smoke going. Then you could also see, of course, the flame. You could see that the paper was changing color. It was going from like a white to a black color. And I'm trying to think if there was anything else they said. I think that was pretty much the majority of what they said. So they wrote that down. So I was like, all right, so let's go then to ice. Ice is composed of H2O. How many hydrogens is that? Well, it's going to be 2 hydrogens. How many oxygens? Just the 1, so 1 oxygen. So I had them write down observations about ice. An ice cube, well, it's a lot of them are like, okay, it's translucent, it's cold, it's a square. Some of the we had that it was a solid. And then I had them write down the observations as the ice sits out. And the big one here is that it melts. So it melts, which I was like, okay, well, if it's melting, it's no longer a solid, it's a what? It's a liquid, but it's a liquid and a solid kind of right now. So anyways, if they wrote all of that down, it's getting warmer, all that. And then we moved on. And I said, one of the above demonstrations is a physical reaction and one's a chemical reaction. I said, label which one is which. So if you think about it, which one's physical and which one's chemical? And your classmates said right away that the physical reaction was going to be the ice cube. And the chemical reaction was the paper that was burning. And I said, okay, well, what are your reasons? I was like, I'll give you why here in a second and tell you the definition, but what were your reasons? And so for the physical reaction, they said that it only changed states. I believe they put it in different terms. But I think what they were meaning was that it went from a solid to a liquid, and that's all that happened. And they said the paper, you had, I think it was something along the lines of like there was less paper left. So it looked different, it completely changed, like there was less paper when I burned it. So then I was like, all right, that's great. Let's look at the actual definition. And the definition of a chemical reaction is 1 or more new substances made. All right, so for instance, I was like, we had that paper that was C5H10O, was it 6? Give me a second, I gotta look and make sure I'm saying that right. 5. C6 and O5. All right. Put this back down here. So C6. I have the numbers there, just on the wrong one. All right, so what I said is, okay, what do we need? What do we have to get fire to burn? I was like, what does fire have to have? And flames have to have oxygen. Your classmates told me that. That is true. And so then I'm like, okay, well, what do you think is made? When I light something on fire, you guys saw those gases. What are those gases? And in your class, they were kind of like, you know, I had to kind of pull it out of them. I was like, okay, if your house is on fire, they tell you to get on the floor because there are gases that can suffocate you. And so CO2 is that gas. Now something else, another product that is made from this is one that we tend not to think about because it is H2O and it's like, there's fire, yet it makes some water vapor. Okay, plus we're releasing some energy, all right? But anyways, I look at that and I'm like, okay, well, look at this. I have 10 hydrogens on this side of the arrow and I only have 2 on this side. So how do we do that? Did some hydrogens just disappear? And we know that's not possible. We have a thing called conservation of mass. And that means that if I start with 50 grams of hydrogen, then I must end with 50 grams of hydrogen. Now it may look different. It may not be in the form of paper. It may not be in the form of water. But you cannot just, things do not disappear. Matter does not disappear. So this is why we balance. And that's what we'll get into in the next section. All right, now physical reaction definition. I'm trying to remember, I don't have my notes right in front of me, so I'm trying to remember exactly what I told them for that. Let me pull this out here. It's the state, basically chemically a substance is not changed. So chemically, a substance doesn't change. So what I get is I get H2O that was a solid when it was ice, right? And then when it starts to melt, I get H2O that's a liquid. So that's what that S and L is standing for. And you'll see more of that throughout this chapter. Add water that's a solid, that's why I put an S. I put water that is a liquid. Now if I let it sit out on the table and it eventually, there was no more water, it evaporated, I'd say it now turned into H2O and I'd put a G for gas. So those are some different ones, which we'll see those later on. All right, so not too much more here. So then we had a learning check and it was like, okay, are these chemical or physical? Some are a little bit trickier than others. A rusty nail is chemical. You have an iron nail, and when it's in the presence of oxygen, we make iron oxide, and that's the rust. Tarnishing silver, a lot of times kids don't know that one. It's kind of similar to a rusty nail, so it is chemical. Bleaching a stain, that is chemical. Anytime we have like a color change of some sort, it's chemical. Tearing paper is physical because it's still just paper. I can tear it in half. It's still composed of the same chemicals. Burning a log is chemical. Anytime we see fire, it's probably going to be chemical. That's just like me burning the paper. Sawing a log, that is physical. It's still the same thing. Fermenting grapes. Now, a lot of people are like, what is fermenting grapes? And when you make wines, you ferment grapes and you produce an alcohol. So you're making something chemically new. Boiling water is physical. Breaking glass is physical. And sour milk is chemical because you are making, it's a little bit more acidic. You're making new chemicals when milk sours. All right, so here, this is about a 4 to 5 minute YouTube video. They will talk about 5 different types of evidence that will kind of show you that you have a chemical reaction. So we watch that video, and as they watch the video at the very end, they go through these 5, and I have the kids write those down. So just watch the video and do that. If you have, we didn't have any homework today. We'll have some homework tomorrow. But if you have any questions at all, let me know. And I will, hopefully I see you soon. All right, have a great rest of your night. Bye.